could just start at the beginning.
Sure. All right, and you will see that snip here shortly. It says examine the graph of the polynomial function below. How many turning points does it have? So this is pretty easy. I'll just label them. There's 1 there, 2, 3, 4, 5, and 6. Turning point is either like this or like this. So this one has 6 TPs or turning points. Is that okay?
Yeah.
Okay. So I'm going to grab, let me get the next question, and then I'm going to snip in the graph with each one because it'll be much clearer to do if we have a fresh picture each time. So it says as x goes to infinity, okay, what does y do? So that means this side over here, as x goes to infinity means to the right here, like you're basically going along the x-axis here. So it looks like f of x goes to infinity. That's what this y means going up here.
Yeah.
So it's generally like this. You would say as x goes to positive infinity, y goes to positive infinity.
Okay.
All right. So then we can actually ask the same question when we go the other direction. So we'll put that here, and it says as x goes to negative infinity. So that's on this side here. Basically, you're going left. So as x goes to negative infinity, y goes to negative infinity. All right, so D is really an odd question here because it probably should have been asked after C. I'm sorry, after A. The degree of the polynomial is equal to the number of turning points plus 1.
Yeah.
So we had 6 turning points plus 1, so this is odd because it's 7 degree. It could actually be higher than 7, but we'll ignore that unless it asks. It might ask here. Oh, well, that's what it asks in E. Boy, a lot of weird ordering of these. So if this isn't, if I'm not giving you enough explanation, let me know. I can provide more.
Okay. Yeah, I got this part. But...
Okay. So the smallest degree is exactly what I just said here. It's 6 plus 1, which is 7. Is the leading coefficient positive or negative? So the answer is based on the fact that since it's odd degree, there's 2 possibilities for odd degree. The first is that it starts low and ends high, or starts high and ends low, and it does whatever it does in between. Okay, this is if the leading term is positive, and this one's if the leading term is negative. So since your graph looks like this, it's a positive leading term.
Okay.
It's basically a definition. That would be the explanation, I suppose.
Yeah.
Okay. Wow, all of a sudden you get to G, and G is kind of this gigantic problem here with no room to do it in.
Yeah.
All right, well, that is the way factor form, that's not so bad. That's not so bad. Okay, so it actually has zeros at -2 twice, which it doesn't really say that, but because it touches, not crosses, that means it's a double root.
Okay.
And that means when you write it in factor form, you're always writing like x minus the 0, like whatever value it crosses or touches at. So for your polynomial function of x, there's always an a out in front. We'll talk about that. And then it's x minus 2, x minus 3. That takes care of those two. X minus 1. Now x minus -1 is really x plus 1. X minus -2 is x plus 2, but as I mentioned, that's the double root, so you put a little squared there.
Oh, okay.
Okay, so that's important. Now it goes through this point, 0, 2. That means that this is 2, and that you're going to evaluate for x equals 0. So it ends up being 0 minus 2, 0 minus 3, 0 minus 1, 0 plus 1, 0 plus 2 squared. Okay, so simplifying here, on the left, you're going to get -2, -3, -1, +1, and then 2 squared is 4. So we got to calculate this. This is 6, this is -6, -24. So I get 2 equals a times -24. And then you solve for a. So a equals 2 over -24, which is -1 over 12. And then you rewrite it up there, but you put that a in. So I'm going to sort of help myself here, and I'm going to copy it down here. Hopefully it copies nicely. It did. And then I'm going to replace that a with -1 over 12.
Okay.
And that's all for that one. It's quite long if you had to actually expand it, which it looks like you have to do that in number 2 here. Okay, so you let me know if I need to make more explanation or if we need to skip any of these problems. So this one has a polynomial. It says of lowest degree with real coefficients that has 4 and -3i as some of its roots. That's interesting, and contains the point 0, 4. So the 3i here, -3i comes in a pair with 3i. These are conjugate pairs. They always come together in pairs, which means that if they don't give you one, you're supposed to know that it has them. So we can write our polynomial of x again as a times x minus 4. X minus 3i gives you plus 3i, and then x minus 3i here. Now it says sum of roots. That means there could be more here, but you can effectively ignore that for this problem because it says lowest degree. So the lowest degree here will be a 3rd degree polynomial. So polynomial of x here, a x minus 4. We're going to expand this on the right here. So you get x squared minus 3ix plus 3ix minus 9i squared. If you remember, I squared equals -1. So that produces, get caught up here, the middle terms cancel. -9 times -1 gives you +9, so it gives you x squared plus 9 here. This is a pretty good opportunity to substitute in the value for a. I'm sorry, not the value for a, to find a. So it goes through the point 4, 0. So we're going to say 4 equals a, 0 minus 4, 0 squared plus 9. So 4 equals a, and this is -4 times 9, so that gives you -36. A equals 4 over -36, which is -1 over 9. We're not done though, because it wants it in expanded form. So we're going to take this line up here, and we're going to write -1 over 9, x minus 4, x squared plus 9. And you need to expand on the right here, expand this binomial. So that gives you x cubed plus 9x minus 4x squared minus 36. Generally, they want it in descending order. That means that the x squared comes next, the 9x follows, and the minus 36 follows. And then we can distribute in this -1, 9. So it's -1 over 9x cubed plus 4 over 9x squared minus x plus 4. And that is your final answer there.
Okay.
Not really enough room to do that, in my opinion, but there's that's what we've got here. Okay. Divide using long division. Okay, let me move this down just slightly, make this a little bigger. Yeah, I guess that'll work here. Okay, so first thing you're looking for here is like, are these all in descending order? And they are, like, and there's nothing missing, so we're in good shape. You have to use long division. So to do this, you figure out, what do you multiply x squared by to get x cubed? And the answer is x.
Okay.
X times x squared is x cubed. X times 2 is 2x. You put them in the order or in the columns that they fit with. And then this is the part it's a little bit awkward, but you're subtracting. So you're going to subtract both of these, or you can change the sign of both, which I like to do. This gives you 0. It always should give you 0 there. There's nothing here under x squared, so it just comes down plus x, and then we don't need to quite bring that 1 down yet. So what do you multiply x squared by to get 5x squared? The answer is 5. 5 times x squared is 5x squared. 5 times 2 is 10. You're subtracting, so you change the sign of both. Okay, so these cancel, x comes down. Really, this 1 should have been brought down, so it's minus 9.
Okay.
So the answer is x plus 5 plus x minus 9 over x squared plus 2. It's the quotient, remainder, divisor. So it's always quotient plus the remainder over the divisor.
Got it.
Some textbooks show this slightly differently, but that is more or less how you would do this problem. Okay, number 4 is set up as if you need to do long division, but it says do it using synthetic division. So we will for sure do it using synthetic division, since that's much preferred. So you have to figure out what goes in the box over here. I call it the box, and it's whatever makes this equal to 0. So that's 2. It's not -2. It's setting x minus 2 equal to 0 and solving for x. Then, and this is very important, is you have to put the coefficients here, but see how there's a 0x squared that isn't written? Your instructor did that intentionally.
Okay, yeah.
2 minus 5, 0x squared, 1x, and 7. And now this is the part where it's much faster and better. You just bring this 2 down, and then you multiply 2 times the 2 in the box. That makes 4. Add them up, that's -1. Multiply -2, add them up, -2 times 2 gives you -4. Add them up, -3, -6 here, and 1. So this last one is your remainder. It's not equal to 0. We'd like it to be, but it's not. These numbers here on the left, they all go down by 1 degree. They go down by 1 degree. So it's not, this was 2x to the 4th, so this is 2x cubed minus 1x squared minus 2x minus 3. And if you recall from the last problem, it's always quotient plus remainder over divisor. All of this is our quotient. Our remainder is 1 over the divisor, x minus 2.
Okay.
Okay, on to number 5. Number 5 is the type of problem that requires its own sort of lesson to like really understand how to do these. What your instructor does not want you to do is this, which is actually totally reasonable to do here because it's not that bad and there's a lot of repetition, but they don't want you to do that.
Yeah.
So there's this thing called Pascal's Triangle. You probably saw it in class.
Yep.
And we just have to know to do this to be able to get the coefficients for this. So this is, I believe it's row 0. So then we want row 4. We want row 4. So that's 0, 1, 2, 3, 4. So we want these coefficients here.
Yeah.
So the way you expand this is there's a coefficient, which we're going to get. And then you take the first thing to the power of 4, the next thing, which is 2y, to the power of 0. And the reason it's 0 is you always start at 0 here. You always start at whatever exponent you started at there. These two exponents always have to add up to 4. Okay. So in this case, it's 1 x to the 4th, 2y to the 0. The next coefficient, we grab 4, grab that 4 there. It's x cubed, 2y to the power of 1. So notice this one went up by 1, this one went down by 1. So then we grab the next coefficient, 6x squared, 2y squared. Then we grab the next coefficient, x to the 1, 2y cubed. And then the last coefficient, x to the 0, 2y to the 4th. So you should see a pattern here. These 4, 3, 2, 1, 0, 0, 1, 2, 3, 4. Is all that okay so far?
Yeah.
Your instructor probably writes it out horizontally. I don't find that to be very useful here because you end up needing to like evaluate these. So it's x to the 4th, 2y to the 0. So that one's just 1. This whole thing becomes x to the 4th. This one is 2y to the 1st, so it stays itself, times the 4, that's 8y, times x cubed, so it's 8x cubed y. This next one's got a little bit more to it, so it's 6x squared. 2y squared is 4y squared, so this becomes 24x squared y squared. This one's 4x, 2y cubed is 8y cubed, so that becomes 32xy cubed. X to the 0 is 1, so this is 1 times 2y to the 4th. 2y to the 4th is 16y to the 4th here. And you just grab all these and now you can write them out horizontally. So it's x to the 4th plus 8x cubed y plus 24x squared y squared plus 32xy cubed plus 16y to the 4th.
Got it.
Great. So that's done and we can move on to 6. Is that okay?
Yeah.
This is weird. I don't know why you wouldn't look at the graph for this. This must be something your instructor emphasizes. That is weird because you would always look at the graph. Okay, so here's I think this is what you may have to verify this instructor. This cube means at most it has 3 real roots.
Yeah, I think so.
Okay, and then there's something in your class, I don't know if it's the fundamental theorem of algebra says this, but there's something else that says it also has, and or it could have 3 minus 2, which equals 1 real root. 1 real, and that means it could have 2 complex zeros. Okay, and you might be like, well, how would that happen? Well, let's say it looks something like this. How many times does this, it has 2 turning points, it hits once, so it's got 1 real and then 2 complex roots. Do you follow that?
Yeah.
So I think the answer is, it could have 2, your choices are, it could have, let's do this, real and complex. Here are the possibilities. It could have 3 real and no complex, or 1 real and 2 complex. And I think this is what it's asking for in part A.
Yeah.
Not sure. Oh, part B. Part B is right here as well. Part B is this discussion right here. It either has 3 real. So let me describe that. This would be like 3 real. 1, 2, 3. And then it has, or it has 1 real, like the graph over here that I showed you.
Okay.
How many non-real zeros could it have? I don't know what your instructor means by that. So, okay, let me try to explain as best I can. We may have to go back to A and B. So
Okay.
I think A is actually asking you to like figure out the zeros.
Yeah, I don't know how to do that.
Without actually looking at the graph, which is pretty complicated. We're going to have to look for the graph, or look at the graph. But what I think your instructor is asking about here is real plus non-real equals total zeros.
Okay.
And I feel like we've already had this discussion. It's like there's either 3 and 0, or there's 1 and 2. So this is like to me, this should have been A. I know that I'm not trying to criticize your instructor or tell you what to do, but like this should have been A. And then the question in A, which is how many complex zeros does it have, that should come down after doing G, where we figure out the real zero and then see if there's 2 more or not. So we'll probably come back and answer A after we do F and G. But if you're trying to figure out what to put down for C, I think it's this discussion right here: zero, real and non-real. Oh boy,
Okay.
really weird. Your instructor.
Should we just put it in the graph anyways?
Yes. I mean,
it's so weird.
It's like telling you not to use your calculator when you have one, on your phone. I mean, it's right there. Like, of course you're gonna do it.
Right.
I've helped other students in your school. I've seen this, and I still don't really know what the instructor. And I believe he or she reuses this, so they either know a lot more than I do,
yeah.
or they have no idea, and they're just guessing big time. Anyway, part D. Okay, positive zeros. So you're looking for sign changes. And you might be thinking, what do you mean by a sign change? Well, this is positive right here. This is positive. This is negative. I know it's a subtraction. This is positive, and this is positive. Okay, so what's a sign change? That's a sign change. So that's 1. That's a sign change. That's 2. That is not a sign change because it stays positive to positive. So
Okay.
going plus to minus, minus to plus, those both work. So since there are 2 sign changes, that means it could have 2 positive roots, or you subtract 2 from this number, it could have 0 positive roots. We don't know. It just says how many could be. So the could be is 2, 0 is your answer here.
Okay.
Okay. Now, for E, you have to make the following change. You have to find f of minus x, which means to put minus x in for x. And then you do have to simplify. So as a reminder, if it's to an odd power, it changes. Like if it's positive, it goes to negative, and vice versa, depending on what's out in front. And if it's an even power, it no change. So like minus x cubed becomes minus x cubed. Here, minus x squared, the minus x becomes positive, but you have a negative out in front, so this becomes minus 3x squared, minus x plus 5. So let's look at the signs. Negative, 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 positive. Sign change? Nope. Sign change? Nope. Sign change? Yes. So there's 1 sign change. So that means there's 1 negative root.
Okay.
So that's what that says. Great. List all possible rational zeros. Okay. So to do this, we have to refer to the original functions. Let me snip that in here. And there's 2 numbers you're looking at. You're looking at the here. This is called P, and the number in front, that's called Q. And there's this guy, I don't know, Descartes, or there's a bunch of people who came up with this. They said that the real zeros, possible real rational zeros, are P over Q, but they're the factors of P over Q. So sometimes that's confusing. The factors of P are 1 and 5, the numbers that multiply to P. Q is just 1. So the idea is that you write the factors of P divided by each of the factors of Q. So what that means is you take 1 divided by 1 and then 5 divided by 1. So it's plus or minus 1, comma, plus or minus 5. These are the possible rational zeros. This was not a great example, so I would totally understand if you didn't fully get that, but
yeah,
we can find that. Now, did you graph this?
I did. It looks like the first one.
Okay, where does it cross the x-axis?
At -1.
-1. Okay, so I'm just going to draw a brief analogy to driving. If you don't know where you're going, it's hard to get there. Would you agree with that?
Yeah.
Kind of silly. I mean, you can't even believe it, but that's what your instructor is asking you to do to find irrational zeros. They're basically asking you to guess all of these to find the one that works. We're not going to guess. We're just going to use the one that works. And it's going to be a lot more efficient. Never understood why they don't utilize technology here, because you could literally you literally choose the right one, make a mistake in here and not know it. So there's some problems here. So bring the 1 down, multiply by -1, add these up, -4 times 4, I'm sorry, times -1 is +4, add them up, times -1 is -5, remainder of 0. So when you get a remainder of 0, this means that you found a root, a 0, a solution. All these words mean the same thing. Here's what that also means. It means that x plus 1, that's a factor. That's what that tells you. What's left over is x squared minus 4x plus 5. Now you could try forever and you'll never be able to factor this. It's not factorable. So what do you do when something is not factorable?
Quadratic formula.
Quadratic formula. So guess what h makes you do?
Do it.
Do it. So we got a equals 1. That's from here. B equals -4 and C equals 5. So as a reminder, I'll write out the quadratic formula here. Okay, so we've got the numbers here. -4 is 4, plus or minus the square root of b squared minus 4 times 1 times 5 all over 2 times 1. So the inside part, here's the main one that most people mess up. It ends up being -4. What is the square root of -4? Do you recall?
2i.
2i, excellent. So this is really 4 plus or minus 2i over 2. It's really 4 over 2 plus or minus 2i over 2. It's really 2 plus or minus I. So the other zeros are 2 plus I, 2 minus I.
Okay.
And as a reminder, I know we haven't done a lesson in a while. I'm going to send you the screen recording and the PDF of the notes pretty much within half hour of the lesson, however long it takes from the upload. It's much more efficient now.
Okay.
So if you didn't get anything, you can get it then.
Yeah.
All right. I feel like this is a long test. I mean,
it's like 9 questions, but there's a lot of parts.
Yeah, I know. I know that. I mean, it's just tough. So we're gonna get through it all, I think. Yeah. Yeah. The last one's your calculator. So anyway, we'll do this. So this one's sum of cubes, and this requires a formula. There's also difference of cubes.
Yeah.
I had someone taking a calculus exam pretty recently, and I said, you're probably gonna need this formula because they almost always put it on there, and they did. It was a college class, and felt bad for the student because they didn't know it, but this is the formula. So you have to figure out what is being cubed here, and that's 4 cubed. So in this case, your a is x and your b is 4, and you're literally just using this formula over here. You're just rewriting p of x as x plus 4, and then it's a squared. A is the x, so it's x squared minus ab, which is 4 times x, plus b squared, which is the 4, so it's plus 16. So this over here on the right, this is never factorable, never. No exceptions, never factorable.
Okay.
Which means if you're trying to find the zeros, which is what it says here, it says find the zeros, that means you have to use quadratic formula again, because you can get the 0 of this one pretty easily. Okay, so let's do it again. We got a equals -4 and c equals 16. So we got 4 plus or minus the square root -4 squared minus 4 times 1 times 16 all over 2 times 1. So the inside part here is 16 minus 64. You end up getting square root of -48 all over 2. So square root of -48, you're really breaking apart 48. So it's 2 and 24, 2 and 12, 2 and 6, 2 and 3. Circle pairs, you end up getting 4 plus or minus, for each pair you bring one out, 4i square root of 3 all over 2. Divide each of those by 2. And you get 2 plus or minus 2i root 3. So the zeros, like when you're all done here, just to scroll up here slightly, x plus 4, that 0 is -4, comma, 2 plus 2i squared root 3, comma, 2 minus 2i squared root of 3.
Okay.
All right. The next one here, 7b, I almost was going to tell you to graph it, but then I realized it does say to factor. So the factoring here is grouping. And the way I know that is that there's 4 terms. And usually it's a cubic. That's also another kind of indicator. So you take the first 2 terms and you say to yourself, what's common between them? Well, there's an x squared. And you factor that out of both, 3x minus 2. So if it's truly factor by grouping, you write this over here again and you figure out what goes here so that when you multiply in, you get the same thing. And this actually works out nicely. And then you factor out the 3x minus 2 from both. And what's left over is the x squared plus 16. This is not difference of squares on the right here. This is sum of squares, which is known to be prime, but your instructor said here, hey, you can use the quadratic formula. Kind of do, kind of don't here. I'm not going to have you use it. You're setting each of these equal to 0. So the one on the right is 2/3. I'm sorry, the left. The one on the right, x squared equals -16. When you take the square root of both sides, you're going to get x equals plus or minus the square root of -16. X equals plus or minus 4i. So your zeros are 2/3, comma, 4i, comma, minus 4i.
Okay.
All right, last one here. Some more factoring. Last one of this factoring section. So this one's a GCF. This is the one that I tell students, over and over again. This one to look out for because it can just save you a lot if you can see it. So there's an x in all of them, and everything's divisible by 2. So we'll go 2x. So that's x to the 4th minus x squared minus 20. Sometimes here, this type of factoring is called a U substitution. We're just going to do it the way you've always done, which is when there's a 1 in front, 2 numbers that multiply to -20 but add up to -1. So that's your -5 and your +4. Those add up to -1. So again, our goal here is to find the zeros. So we're going to set each of these equal to 0. Okay. Now, the first one is x equals 0.
Yeah.
The next one is x equals plus or minus square root of 5. And then the last one is plus or minus 2i. That's just Those are just from their previous problems.
Yeah.
Okay. 8. Okay, so 8. For 8, I'm gonna switch. Actually, I'm just gonna graph it and then snip it in. Let me. I mean, maybe you already did this, but we're just gonna graph it, and I'm gonna graph it and throw up the result here. So 4th plus 3x squared plus 2x 3x cubed. All right, so this one, snipping in. Okay, I'm gonna make it slightly smaller. So it says round to the nearest thousandth. It's already done here for you. So your instructor is looking for minus 2.179, comma 0.513. And that's it for that part. Find the relative min and max. Okay, so we're gonna look. I'm gonna snip in something slightly different. Come on, that's interesting. For part B. Part B. Okay, so the relative min is here, and the max is up here. So the relative means that like up compared to around it, it's compared to around it. It's higher in the case of a max, or it's lower in the case of a min. And that's it for that.
Okay.
Okay, the next problem is a graphing calculator. Oh no, what degree polynomial best fit the data? I'll snip that in. Yeah, there's a lot of ways to do this that could be right, but I have no idea what your instructor wanted. One way to do it is to find the difference between the points. Do you remember doing that in class? Like between 15 and 3 is a 12, between 1 and 15 is minus 14, between 20 and 1 is 19. Did you do that? And then you find the difference between these two, which is minus 26, and then the difference between these two, which is 33.
Oh yeah, that's good.
That doesn't seem right at all here, but so the other way is you actually just find like a first degree polynomial, second degree polynomial, third degree, and you figure out which one has the lowest error. I'm going to graph this briefly, really briefly, like really rough. So 1, 3, 2, 15, 3, 1, and 420. So I'm guessing that it's something like this. So my guess it's like a third degree polynomial. So do you know how to do polynomial interpolation in your calculator? Yes, no, maybe so.
But I don't remember.
Okay, so in list 1, we're going to put the x's 1, 2, 3, and 4. List 2, 3, 15, 1, and 20. And then I think there's a second calc, something for polynomial, quadrag maybe,
Yeah.
or guess would be cube reg or something. I actually don't have a very good I have to do something else for that. So you did MATLAB. How are you doing on that?
I'm in the cubic reg, but theta in. I'm trying to get it into L1, but I don't know where to go to like edit the table.
So it's like stat, maybe second stat. I don't know, it's
Yeah.
either stat or second stat, something like that.
Oh, yeah, you're right. Okay.
I'm not making any progress on my side. So are you any closer to getting those values?
It's not working. I'm not sure what I'm doing wrong.
Okay. This is a huge limitation of this format. So
Yeah.
so whatever you get for B, like you're going to get something for B. You're going to get Y equals some number X cubed plus some number X squared. These would be positive plus some number X plus some number. Part C is you're putting X equals 7 in. So you're going to get a number out. You're going to Y value. You're going to put 7 in for each of these and so on. And then is it interpolation or extrapolation? Since X7 is outside the X values. So the X values go 1, 2, 3, 4. It's way out here. It would be considered extrapolation. Let me see if I can get those coefficients for you. Give me just a moment here to log into something else. That'll do it pretty quickly for me.
All right.
And we'll close out the lesson with that. So let me get that for you. All right, so we had 3, 1. What was the next data point? 2, 15. 2, 15, or it was 1, 3, I guess. 3, 1, and then 4 and 20. All right, so stat, regression, polynomial, x is var1, var2. We want a third degree polynomial, and we're going to compute that. This one didn't work either. Okay, it doesn't look like I'm going to help you on that during this lesson because I don't have a calculator that's
Okay.
capable of doing this. So maybe ask a friend. Let me see if I can find TI 83. Cubic regression. So this one, here's a video. This video looks pretty complete here to do what you want.
Okay.
So try that, and that is all for today. So I will be, thanks for scheduling. I'll be sending you these notes out and then the screen recording here shortly.
Okay, thanks, Matt.
Thank you. You're welcome. Bye now.
Bye.